Hi guys, welcome to a new series from 8-Bit Panda. This series will be taking you through the installation configuration of VMware, starting from ESXi, working our way through to the install of vCenter and potentially add-ons and other products that can be used in conjunction with VMware in order to make the best of your environment. So the first thing we're going to be looking at today is the installation and configuration of an ESXi server. As you can see on my screen, I've got a VMware workstation deployment. Inside that I've got some hosts and firewall and a NAS device that will be presenting our storage in this lab. So these installations that we'll be going through are exactly the same as if they were in a physical hardware environment. What is VMware? And what is ESXi? VMware solves the problem of having multiple physical servers consuming high amounts of power and not utilizing the full hardware that is available to them. So when we install VMware ESXi onto a server, what happens is it utilizes the full memory and CPU and it passes that on to virtual machines that are hosted on the ESXi hypervisor. It means that you can run less servers but more virtual servers, reducing costs in hardware and reducing costs in power. So now let's start by first off powering on our virtual host. So as you can see, it's asking us to boot from the media. It'll boot within 10 seconds and then it will start to boot onto the installer automatically, or you can press enter and that'll take you through straight into loading the ESXi components into memory, and then it'll begin the installation. If you want to download the media, you can get ESXi for free off of the VMware website. You need to either burn these to disk or use something like a remote management ILO, something similar to an iDRAC on Dell or an ILO on HP. And you need to make sure that one of the things that you do is enable virtualization technology in the BIOS, otherwise you'll get errors whilst you're doing the installation. Another thing to make sure that you do is to check the power options within your BIOS. Most platforms will either have this disabled or set to use an eco mode of power. What that does is it reduces the performance of the processor and it also reduces the performance of the memory by using less when it thinks that you don't want to use the full potential. So that can cause issues with applications that are specifically CPU intensive, where they require the full capacity of the CPU. The server might not be drawing enough power in order for you to get the full potential out of that CPU. So one of the recommendations is you can either set this to be maximum power, which will basically use all of the power available and give you the most performance potential out of your hardware. Or what you can also do is set this to performance per OS, and what that will do is it will allow you to control the performance through VMware and allow you to change those settings in there. So once you've done that, attach the media to the server, boot the server up, and we'll start to go through this installation process. So as you can see, first screen that we get is welcome to the ESXi installation. One of the things it's going to check is that you have made sure that ESXi 6 is supported on the hardware that you're using. If it's not supported on the hardware that you're using, you could get errors during the installation, or you will find problems whilst you're using ESXi. Certain drivers won't be available, or you'll start to see performance issues. So we'll just press enter onto that, and then we get our end user license agreement. I don't think anyone ever reads these things, but we'll continue through that anyway. What it's doing now is it's going to scan for any available disks. It'll look for all of the drivers and make sure that everything's correct. As you can see, we've got 3 disks available to us. We've got a 6 gig disk, a 5 gig disk, and a 40 gig disk. I'm going to go ahead and install this on our 6 gig disk. And I'm also going to choose United Kingdom for the keyboard layout. So now we need to supply password into VMware. You can leave this blank The issue with leaving it blank is that you can't add it into vCenter server when it's a blank password. vCenter server will require that it is a complex password. So I'm going to enter in a complex password. And there we go. So now it's going to gather additional information about the system. It's finished scanning, and we've now got a confirmation that the installation is going to be starting soon. One thing that it does warn us is that the disk will be repartitioned. This means that when we commence the installation, so as soon as we press F11, it will wipe all of the data off of that disk. So we're going to press F11 and the installation will begin. We're going to leave it to install and we'll be back shortly. Okay, so as you can see now the installation's finished. What we're going to do is press enter. This will reboot the server, and then once it's rebooted we'll just go through a few basic configuration steps. Our server is now booted. As you can see, it shows some information on the screen there. Basically gives you the specification of your server, what version of the software is installed, what processor your server has, how much memory it has, and you will also see the IP address. As you can see at the moment we don't have any IP address. If we press F2 then we can log into the server. This page that we're looking at now is basically where we configure our majority of settings in order to gain access to ESXi. So once you've done this, then there's really no need to use the ESXi console anymore. You won't need to get onto the screen of the server unless, for example, management access becomes unavailable. So we've got a few options here. We can change our password. We can configure lockdown mode. Now you'll notice I can't actually select this option. This option will only become available once we've added this server to a vCenter. We'll go through that setting once we do the vCenter on our next episode. So we can configure our management network. First off, we have our network adapters. In here, these are the network adapters that we're going to use in order to manage our host. So initially you'll see that only one is selected. For our server we actually want two to be selected. However, I'm not going to do this at the moment. The reason being is that when we configure VMware for the first time, it actually has duplicate MAC addresses. One of the things it does is the first VM kernel that it creates it with the same MAC address as your VMNIC 0. The issue that this causes is that if you've got switches that are in a stack, it picks up that there's two MAC addresses that are the same going across the network. That causes the interfaces to flap and you lose management on your hosts. I'm just going to leave it as one at the moment. So if your network's got a VLAN tagging and you need this to be on a specific VLAN, this is where you will fill in that information. We don't need it to be on a VLAN at the moment. IPv4 address. What we're going to do is here we can either disable IPv4, we can use a dynamic IPv4, so it'll pick it up from a DHCP server, or we can set a static address. I recommend setting a static address. That depends though. If you're using something like auto deploy, you might want to do it a different way. It really does depend on the environment that you're working with. First thing that we're going to do is set the IP address and our default gateway. Press enter and that's set. So another thing, I don't have an IPv6 network, so I want to disable this. It does require a reboot. Set our DNS, so I recommend that you choose a server that's more relevant than Google, and then set host name. So this host name is what the server will be known to across your network. I would recommend not using any version names here. Problem with using version names is that when we come to upgrading our host, it's then incorrectly versioned. I tend to use ESXi. Your DNS suffix, this is your domain name. In this example, we're going to use lab.local. We'll escape out of this, and then we'll press Y to accept and apply these changes. So it's going to reboot the host because we've disabled IPv6. I'll let reboot and then be back shortly. Another thing that you guys might find quite interesting is that when VMware is booting, if you press Alt F1, it'll actually show you in much more detail what's actually happening. It'll show you it loading drivers, for example. It'll show you it scanning the disk drives. It will show you any errors that are potentially happening when the server's booting up. What we're going to do now is log back in. Oh, and to get rid of that screen, if you press Alt F2, and that'll take you back into the yellow and grey screen. So we've now configured our management address, we've restarted the server, so let's test it, see if it works. Hopefully should get a response from our router, which we do. We may not get a response from Google on this particular lab. It's not set up for internet access, so they will fail. Normally those will both succeed. So we've also got network restore. A network restore allows you to reset the whole network back to the defaults. This can be handy if someone's changed the setting and we've lost management access into the host. We can just do a restore and we can restore the network settings to defaults. We can change our configuration of our keyboard, we can do some troubleshooting, we can view logs, support information, and we can reset the system to factory defaults. One of the other things that I actually wanted to show you was the issue with the duplicate MAC addresses. First off, go into the troubleshooting options, change ESXi shell from disabled, then you press escape, press Alt and F1, and that'll take you to a login prompt. In the login prompt, type the username root and your password. Once we've done that, you'll see looks a lot like Linux. What we then need to do is run the following command. Now, what this is going to do is it's actually going to show us what MAC addresses our system's using and what MAC addresses the vSwitches are using. These are the physical NICs, and then what we're also going to do is ESXi VMK NIC-L. So a VM kernel allows management access, vMotion traffic, and also fault tolerance across it. These all have IP addresses, they all have MAC addresses, but the actual vSwitch itself doesn't have an IP address and it doesn't have any MAC addressing. So when we press enter, we should see a list of any VM kernels and also the MAC address of those VM kernels. So as you can see, our VM kernel has the same MAC address as the physical network adapter. As I said before, this is a feature of VMware. There is a KB article which is listed in the description that relates to this issue. We need to fix this before we go forwards because it could cause us issues on our stack and we don't want those MAC addresses to be the same. So the first command that we need to run is ESXCFG-VMK-NIC-D and then the name of the port group. So the name of the port group you can find here is management network. Put this inside speech marks. What that's done is that's now deleted that VM kernel. If we want to check to make sure it's definitely gone, we can just run the vmnic list again. And as you can see, there's now no more VM kernel there. So we need to recreate this, otherwise we can't get onto our server in order to manage it. So we do the same again, ESXCFG-VMK-NIC -A, which is to add, -I, which is the IP address. Then we do -N, which stands for netmask, it's 255.255.255.0, and then the port group name. Okay, so we've recreated our VM kernel now on our management network, and if we do the list again, you'll see now the MAC address that was CF is now 04. So that has now resolved our issue with having duplicate MAC addresses on our network. So now that we've completed that, press Alt F2, so it'll take us back to the proper GUI screen. We can disable the ESXi shell, and then we'll log out. For the next configuration steps that we need to do, we actually need the VMware VI Client. So what I'm going to do is just jump onto that. Now what we're going to do is go to download the VI Client. The VI Client is basically where we do all of our configuration and management of the host. If you're just having a standalone host, this is how you'd manage any virtual machines that are on the host, and this is also where you would do any reboots or anything like that. So we'll go to our IP address, click continue, and then what we can do is click download vSphere Client for Windows. When we download this, we just need to install it, and then we type in our IP address and usernames. So I've already got this installed on my system, so I'm going to type in my username, and my password. Notice I've already got the IP address typed in. Click login. Get a warning for a SSL certificate. It's because it comes with a self-signed certificate by default. If you want, later on you can put a proper certificate on there. Click install certificate and then click ignore. One of the things that we do need to do is we need to configure our networking. So at the moment we've got the bare bones networking. It shows it in a nice GUI here so you can actually see what's happening within the network. The grey area is almost like a physical switch with the VM NIC on the right hand side. This is basically your uplinks to your router, for example, off of your normal physical switch. To the left hand side we've got port groups. So port group is basically a interface on your switch. Any of those interfaces can have VLANs on them. Those VLANs will pass through onto your physical switches, and then your physical switches, if they support VLAN tagging, will be able to split out that information and pass it around your network to the correct locations. So what we're going to do is we're going to first off add a second network adapter. By doing this we click properties, choose network adapters, click add, and we tick on the next network adapter that we want to add. In this example we're going to use VMNIC 1. In a physical world I would recommend that you use 4 onboard NICs and you have 4 offboard NICs that are using a riser card that are separate. The reason for doing this is that if one of those boards fails, then you will still be able to function correctly. The likelihood is that if the riser card fails, all 4 NICs will go, and the same on the other onboard NICs. So it just makes sense to split those out, and we're making ourselves a little bit more resilient. So now we've got 2 NICs. What we're also going to do is we're going to configure a storage network, vMotion and fault tolerance. One of the best things that you can possibly do is to separate vMotion, fault tolerance and management traffic so that they're all using in their own set of NICs. In a lot of situations that's not going to be possible. The reason for splitting them out is due to traffic. So vMotion is quite hungry for network usage, so I'd always recommend that this is set to active on one NIC and passive on the secondary NIC, and that management traffic and fault tolerance logging are put on the other NIC if you don't have enough NICs to separate them all out. So at the moment we've just got our management network on there. What we're going to do now is we're going to add vMotion. So if we click add, we'll then choose VM kernel, then going to tick the box that says use this port group for vMotion, and we're going to name it vMotion. For our VLAN we've got VLAN ID of 16, click next, and then in our IP address we've got 172.16.199.11. Click finish. So we've now got our vMotion network adapter. The only issue is that vMotion and management are now using both NICs on the switch. So what we want to do is open up the vMotion again. We need to go to NIC teaming. We need to tick override switch failover order, and then what we'll do is we'll move VMNIC 0 to a standby adapter. So we've got 3 different options for an adapter. You've got an active adapter. An active adapter is live, so if you've got 2 in there, load balance between the 2 depending on your configuration. If you've got standby adapter, it'll use the active adapter as its primary adapter, but should that become unavailable for any reason, it'll start to use the standby adapter. If we put anything under unused adapter, this basically means that it won't use it under any circumstances. We've also got load balancing policies. Now load balancing policy, the only time you really change this is when you have switch configurations that depend on changes here. The route based on the original virtual port ID, this tends to be used when there's no configuration whatsoever being done on the managed switches. Route based on IP hash, this is normally used if you've got a port trunk. For us, we're just going to leave it on default because our switching deals with everything else. You have network failover detection. Again, this depends on the switches that you've got, but usually you'd use link status only. Notify the switches. If you've got smart switches, the vSwitch can let the switch know when there's any issues and fail back. Do we want to fail back to our other VM NIC when this failover occurs? If not, we leave it as no. We've also got other options. Traffic shaping. Traffic shaping allows us to limit the amount of bandwidth that's being used by either a VM kernel or a vSwitch. If we're setting it by the VM kernel, then we would choose the VM kernel as we've got at the moment here. Tick this, click enable, and set our limits. If we're trying to do it for the vSwitch, you'd edit the vSwitch and do exactly the same thing on the vSwitch. Promiscuous mode basically sets the switch so that any traffic sent anywhere on the switch is accessible by any other traffic that's on that switch. It's a bit like turning a switch into a hub. I would highly recommend that this setting is not used unless you're doing some packet sniffing for NetFlow analysis or something like that, and your licensing doesn't allow you to do NetFlow. MAC address changes by default is a set accept. This is whereby your devices may require address changes such as load balancers, firewalls, things like that, where you've got an active passive cluster. Forge transmits allows you to spoof your details and basically pass that information through. We've got our IP settings, which we've already set up, and then we've got our MTU settings, names, VLANs, which we already did at the beginning as well. So if we click OK, that's now changed the configuration, so it will only use one of the VM NICs at a time. We're going to do the same to the management network, but instead of putting VM NIC 0 into standby, we're going to put VM NIC 1 into standby. All our other settings should be left default, and you'll notice management traffic is ticked to be enabled. I'm going to take you through the vSwitch just so that you can see what settings we've got in there. We've got a number of ports. The ports are much like ports on your switch. Each virtual machine uses up a port. You've got MTU. This is the size of the packet that gets sent. If you're sending over iSCSI traffic, then it's wise to set this to jumbo frames if your equipment supports it. You need to check that. If you set to 9000, which is for jumbo frames, then you'll start to see packet loss if the rest of your networking equipment and your storage is not set up the same. As you can see, the default set reject, accept for promiscuous MAC and Forge transmits. Traffic shaping is disabled in this example, and we want both of our NICs to be active for the switch. If we set this switch to have one active and one standby, it means that VM NIC 0 is the only one that will be used, and the only ones that will override that is where we've set it specifically. So for example, vMotion and management. So we've now got our vMotion and our management set up as we want them. We're also now going to add a fault tolerance in there. So fault tolerance is a VM kernel as well. We'll click next, we'll name it, and we'll tick use this port group for fault tolerance logging. We'll also set our VLAN. So we'll set our IP address and we'll click finish. Again, fault tolerance, we don't want this to run on the same as our vMotion. So we'll move that off. Next step is to add our IP storage network. So this again is a VM kernel. We're going to call this one IP storage 1. Our VLAN is VLAN 17. We're going to click next, type in our IP address and our subnet mask, and click next and finish. So for IP storage, what I tend to do is we set one NIC to be active and one to be unused, and we'll set up our secondary one. And on the secondary one, we'll change our NIC teaming so that it's in the opposite order of storage 1. As you can see in here, we've got storage adapters. If you've got a HBA on your storage controller, these will show up here. Otherwise, you will just see your HBAs, which are your local SCSI HBAs. If we click add here, we can add a software SCSI adapter. So software SCSI adapter basically allows you to connect to iSCSI storage without having a physical HBA in there. This is particularly good if you don't have the money to spend on a physical HBA, because they can be quite expensive. So now that I've added this, I'm going to go to its properties and we'll have a quick look. We can set up CHAP authentication. This again will depend on how you've got your storage set up on your own platform. I'm going to go into advanced, There's a lot of settings that we can set in here. One of the things that most storage vendors tend to tell you to disable is delayed ACK. What delayed ACK does is this basically will delay a response to a packet. The reason for that is that it can build up more packets and then it can send out a bigger chunk of data. The problem with this is it does cause higher latency and in some situations can cause performance issues. And another thing that we're going to change is the login timeout. We're going to set that to 60 seconds, which is the maximum. 5 seconds, sometimes what tends to happen is you'll log out and you'll have disconnect issues. Click configure here, we can set our iSCSI name and alias if we wish. Network configuration. Under here we should now see that we have IP storage 1 and IP storage 2. If we don't set these up correctly, so if we set them up so that they're using more than one active NIC at a time, then these will be greyed out like this, and that's because they have more than one physical adapter associated with them. So what we're going to do is we're going to add both of these in here, and this will now allow us to communicate with our storage. We click dynamic discovery, we click add, and we type in the IP address of our storage device. Click OK. This will take a little while, but what it does is it basically adds that IP address, makes sure that it can communicate with the device on the other end, and then we will rescan our storage, which will pick up any iSCSI LUNs that are available for this particular ESXi host. As you can now see, we've rescanned our storage and we will now see 4 devices. These are our connections to our disks on our SAN. And from these we want to make a volume that we can store our virtual machines on, and that we can also store other information on, like crash information. So that if an ESXi host crashes, all of its information will be stored somewhere and we'll be able to get that information back to diagnose any issues. So go to storage, click add storage, and then we'll select disk or LUN. As you can see, we can see the 2 local disks that aren't currently in use, and we can see 4 free BSD disks. For this we're going to take the first one, which is 60 gig, and then we'll click next. Choose data store name, click next. Choose maximum capacity, or we can choose a different capacity if we so wish. The recommended setting is to use 1 LUN per volume, so you have 1 data store on 1 LUN. The reason for this, better performance, easier to manage as well. Tend to use maximum available space here. Click next. It gives us a summary and we click finish, and then we can see our data store is now here. If we want to, we can change the name. Doesn't matter if there's virtual machines on there because it doesn't use that name in order to communicate with the hosts. One thing we are going to do, which is for the crash information, is we're going to set a folder within the data store. So if we click browse data store, you can see in here, and then we can just click new folder. So what I tend to do is call this .scratch, press enter, and then our scratch folder will turn up here. And then I also create another one for each ESXi host. So this is ESXi 1, so we'll close this down. And one thing that we do need is the full path location to the storage. Another way that we can get this GUID, which will allow us to actually copy that, is to do it through command line. What we'll do is we'll do it that way because it's much quicker. Go to security profile, click properties, and set SSH to be running. We then want to open up an SSH window. You should be able to just log in with your root credentials. Then do ls. And in here we can see all of the directories that are available to us. We want to do cd/vmfs/volumes. Press double tab. In here you'll see all of the volumes that are available to us. If we go to our folder iSCSI, we then get our full GUID. We select all of this, which will give us our GUID, click on that, and that's now copied. We don't need this window anymore. Click OK here, and we'll click Advanced Settings. So under Advanced Settings, we then want to go to syslog, Global, and under Scratch. What we do is we paste 2 brackets, paste in our GUID, /scratch/ESXi1. What that'll do is it'll change, so we click OK. That's now created, but won't take effect until we reboot the server. So we'll go into here again, just check that the setting is there, and as you can see it's now set that into there. Click OK and we're now done. I've got another few little things that I recommend that you do set. The first thing DNS and routing. Just double check, make sure all of this is set correctly. Time configuration, that's quite an important one. As you can see, my time is out. What I'd do is enable the NTP client, set this to start with the host, click NTP settings and add an NTP server into here. I'm just going to add UK pool, click OK again, and there we go. Our time will update shortly. You can see licensed features, so in evaluation mode you get all the abilities that you can do. This is the full Enterprise Plus licensing. Most people probably won't be using the Enterprise Plus licensing unless you work for a large organisation, but I've got to say it's definitely worth the extra money for the extra features that you get. Distributed switches add a lot of functionality, means that you can do a lot more with VMware. It just makes the product complete, makes it much easier to use and much better. So we've got our time configuration. We can also do authentication. Authentication can be with Active Directory or local. To add it to Active Directory, you just type in your domain name, click join domain, and that's it. It's as simple as that. It'll prompt you for your credentials and it'll join it to the domain. We can set startup orders. This I would only use if you're using the host standalone. I wouldn't use it for any other reason. The security profile. In here we've basically got a firewall and we've got services. By default there's a select number of services that are required. Those are on. Anything that's not required is stopped, and it needs to be started by clicking properties and then choosing exactly what it is. By default SSH is stopped. I turned it on for this demo, so I'm going to stop it again because it's no longer required. So earlier on I was talking about the need for setting the power management up in your BIOS. The reason for doing this is due to performance. Another thing to bear in mind is VMware also sets this setting, and if you're not careful, you leave this imbalanced, then you won't get the best performance. So what I recommend doing is click on properties and choose high performance. What this will do is it'll ignore anything that the BIOS tells it, and it will just use as much power as it possibly can. That will give it the best performance possible. So we'll click OK. When we refresh this page, it'll change to high performance. There's one thing that I will do, which is create a new vSwitch. And this new vSwitch, what this is going to be for is any VM traffic. So for this we're going to put server, just for an example. Click finish. Don't need to change any configurations here, and I want both of these adapters to be active because I want to utilize the full bandwidth when I can, and if there's a failure then it'll just jump onto the second one and we'll just have 1 gig instead of 2. So that's all for this time, guys. Thanks a lot for watching. Next time I'm going to go through the installation and configuration of vCenter using the vCenter server appliance. You can also install on a Windows server, but I'm not going to go through that because over time VMware are actually going to get rid of the Windows option and they're just going to push you towards the server appliance. But in version 6 they've done a lot of performance improvements. They've moved it onto new database technologies and it is much more optimized, and it's definitely the way forwards and definitely the way that VMware will be going. So we'll go through that all in the next video. Hope you guys have enjoyed this video. If you have, please like and subscribe. Any comments, I'll try to get back to you as soon as I can. Thanks a lot.